All right, we're going to be simplifying radicals. This is lesson 314. What is 314?
Pie.
Pie. We're having pie today after this. So we got some mamas who brought you some pie because they want you to celebrate math. Are you ready?
That's the last thing I think of when I eat pie.
When's pie? When is pie? All right, now there's a term up there. Remember, it said simplifying radicals. What in the world is a radical? In mathematically. Mathematically, what is a radical? Reel you in, guys. Come on. You guys remember? Can anybody draw one on their board? What's a radical?
Is it like the root or something?
Yes, it's like a square root, cube root. And this is a radical sign right here. The radical sign looks like this, okay? Here's your radical sign. It could be a cube root, square root, third root, fifth root, and so forth, okay?
Well, my mom
All right.
was at CC and she was doing an assembly time and she's like, so kids, why do we not, she's talking about 10 minutes, like, why do we not need to lie? And for some reason I was like, because then you'll sound like Kamala Harris. It's just off the top of my head, I just said that. I was like, oops.
Not cool.
Are we ready? All right. We're going to the groups come out as singles. I want everyone to listen to this. The groups come out as singles. This is kind of a weird thing to say because you don't know what it means yet. But let me show you. I want you to watch. If you had the square root of 16, you just know that by heart. What is the square root of 16?
4.
And the reason the square root of 4 is 16 is because we have 4 and times 4 under there, and those doubles, that group of 2, comes out as a single. Listen, reel you in. We want to get done. We want to have pie. We want to go play, so I need you to hang on with me. Here we go.
Wait, what kind of pie? What kind of pie?
Shh.
Pumpkin?
Gentlemen.
Pumpkin?
Shh. Just listen. Don't worry about that right now. Are we ready?
Pumpkin.
All right. Now, there may be times when you don't have a perfect square root, but we can still simplify it by taking out some perfect squares out of it. I want you to watch. Watch me. 48. We come over here to the side and we do our... Last week we studied prime factorization. This was why they wanted you to do that before. All right?
No.
We have...
No.
What do you want to do with 48?
6 and 7.
Not 6 and 7.
6
6 and
and 8.
8. So I'm going to do 8 over here and 6 over here. Because my 8, I ought to do an automatic 2, 2, and 2. And then this is 2 and 3, right? So I come over here to my 48, and I rewrite 48. Are you with me? I write how many 2s?
4.
4. No. So I write them out. 2, 2, 2, and 2, and 3. Now, this is a square root. Are you with me so far?
Uh-huh.
Yeah.
So the groups of 2 come out as a single. Just come out as a single. Are you with me so far? So I will have 2 2s and a 3 left over. So the square root of 48 will have a 3 in here, and I'll have a 2 outside and another 2 outside. And those 2 2s multiply. What does the 2 and the 2 become?
4.
2 times 2 is
2 squared?
4.
Okay.
48 does not have a perfect square root, but we can pull some square roots out of it so we can still do some simplifying with it later, or adding and subtracting and multiplying with it. So we are simplifying the radical by doing this. Another way of writing the square root of 48 is 4 square root 3. Do this with me. Write 100.
The 4th root of 3? Or
It's 4 times the square root of 3.
4?
This is
It
not
looks like 4
this
into
is
3, like they did.
this is not a little teeny 4 up there. This is a big 4 out front, 4 times. And if you want to write the times, you could, but you know, it's like a 4x. We don't put a little dot in between it.
Okay.
All right? This is like 4
It
times.
looks like it's 4 into 3, though. Like, it looks like a division problem.
Oh, be very careful with that, Zach. It does. Make sure your square roots have that little foot there. Otherwise, it does look like a division problem. Exactly right. And also, radicals have kind of they kind of turn. No, they don't turn.
No, it's just like a
Divisions are either straight or kind of curvy, but they don't have the foot. Okay? So you make sure you put the foot on it, and that's a tiny little detail. All right, let's do the next one together.
Yeah, the radicals.
I want you to write 180 down, please, on your whiteboard. Write 180 on your whiteboard, square root of 180. Then find the prime factors of 180. from the prime factors of 180. How much?
18 times 10.
18 times 10? I agree. And then what about 18?
12 and 15.
And 12 and 15? Okay, all right. I'm going to do 18 and 10. I already started. I've got 2 and 9 and 2 and 5. Am I finished?
No, you had to flip them. Oh wait, no, you have it flipped.
I have the 9, 2 and 2.
2 squared
9 and 3
times
and 3.
3 squared times 5.
Yeah.
All right. Yes. Now, if you want to write them, it doesn't. You can. I usually like to write them when I'm doing my. I like to just write them out, and I put them together. I'll do 2 and 2, 3 and 3, and 5. Are you with me so far?
Yeah, but you don't write 2 squared.
You can. Okay. It's up to you. That's not. All right. I told you the groups come out as singles, and we're doing groups of 2 because this is a square root. How many groups of 2 do I have?
1.
I have a group of 2 right here. Do I have another group of 2?
No.
Nope.
That's the C.
I do, guys. Where's the other group of 2?
3.
The 3s, right here.
Oh, I thought you meant group of 2, and that's.
Oh. I'm sorry. I have partners. Let's do this. How many groups of partners do I have? I have a group. 2 is partners and 3 is partners. Okay. Now the 2 comes out as a single. So what do I put out front?
2.
A 2. And what else do I put out front?
A 3.
And what do I have left over inside?
5.
What do I do with the 2 and the 3?
Square 'em?
No. What's the little dot between the me?
Multiply?
Multiply them. So my answer will be.
But wait, don't you have to have the exponents on them? Like, would it be 2 squared times 3 squared? Because there's 2 of them.
Let me get the answer, and I'm coming back to that question.
So it looks like this?
Almost when we're done. We have 6 square root 5. Okay, Zach, I want to make sure you understand this. I want us to go back to review what square roots are.
No.
Right here, this 2 times 2 means what? Square root 4.
Square root, and that's in the. So you're looking because if it's squared together. Then it's,
Yeah, you could write this as 2 cubed, 2 squared, and these cancel out. Left with just the single, right?
okay.
The reason I don't like to write this because I could have a 3.
That was square root.
I could have 3 of them and only 2 of them come out. So I kind of like to see the partners personally, so that I can.
That makes more sense.
Does that help you now? All right.
I didn't know that. I didn't think that. I wouldn't think that those were in the.
Right. See, yeah. They're under the square root, and don't forget your foot on the square root because then it looks like a division. All right. Please ask me more questions, gentlemen, because you're going to do these by yourself in a couple seconds.
So it looks like this?
Yes, 6 times the square root of 5 is the simplified version of square root of 180 because we can take some perfect squares out.
So do you put it on top of it?
Very good question. You don't put it on the. See how you don't put it on top because radicals aren't like divisions. This is an excellent question. We put it out to the side. Okay, and the answer comes out. If you wanted to be at the very end, you could have square root of 180 equals 6 square root 5. We put it behind it, not on top. Excellent question. All right, more questions. All right. This one is now I want you to try this one by yourself. Notice this is not a square root this time. You're going to have to extrapolate some. I'm sorry, didn't mean to throw that at you. You're going to have to extrapolate this because we're now doing cube roots, meaning I want you to try to think how that changes. But I want you to try it. If you get it wrong, it's okay.
Which one are we doing?
We're doing the triad at the top, the cube root of 270.
Okay.
Would it be 6.5?
We're not doing I don't want to know what it is. I want you to take out the partners or the groups.
That's a cube root.
Pardon?
No, it doesn't. Never mind.
Which one has a cube root?
I Oh, yeah.
It does. I think you're right. What did you say has a cube root?
I thought 270 did.
Oh, 270 doesn't have a perfect cube root. There's something in there that does have a perfect cube root in there, though.
What is it?
27 has a perfect cube root. Yes, it does. You learned that when you were singing your songs. If you guys want to review your cube song, that would be a wonderful thing for you to like.
Yeah, that's what I've already done because that's why I said 6.5.
Oh, because it's somewhere in there.
Because 6 squared would be 216.
So it's pretty close. Yeah. So it's between. Yes.
But how is it different with a cube root?
How is it different with a cube root? That is an excellent question, JD. Okay, so what should I put under my 27? I have 3 things here because when I have C27, I jump. I don't do 2 of them.
3, 3, 3.
3, 3, and 3. Okay, so I'm going to just do this. I'm going to come under here, and what am I? I'm going to write 3,
Oh,
3, 3, 2, and 5. JD asked an excellent question.
I know how.
Over here, we circled partners of doubles,
Yeah,
but that was a square root.
triples.
JD, what is your prediction?
It's triples.
It's triples. With cube roots, we take out triples is his prediction.
I think I've done this before.
You might have. You might have done it a little different. Some textbooks don't teach us where we do the prime factors. I love the prime factor way.
I think I have the answer.
You think you have the answer. Oh.
Thank God.
Or you have a square root. Oh, I see. Okay.
I'll make
Is
sure.
that wrong?
It's not. It's not as concise as you can write it more concise.
There's a way to like.
Write it smaller.
Yeah.
Is it
All right.
like this?
How many people agree with the 3, 3, 3, 2, 5? Okay, so
Is it like
this is cube root I should have wrote here. All right. JD was correct. When we have a cube root, we don't take out doubles. We take out triples. So I have a triple right here. And remember, the groups come out as singles. So what's going to be out in the front?
3?
A 3. What do I have left under the cube root? The 2 and the 5. And what is this in here? It's 2. What's the operation in there? Is that 2 plus 5? Is that 2 divided by 5? Is that 2 times 5?
It's
Oh, would it be
100
times?
times 10.
It's 2 times 5, which is a plain old 10. So Zach, your 2 and 5 together becomes a 10.
So
So
like,
you cube root that on the symbol. Like,
Yes, exactly right.
so I did the 2 times 5. I could have simplified it even more.
Right.
Okay, so the real answer looks like.
I see.
And I loved it when you guys went, oh, because you had already tried it by yourself before. If I just come up here and dictate how you do it all the time, you don't get a chance to make a mistake. And then while you're making mistakes, you're actually going, oh, but I wonder if it's like this, and maybe it's like that. And you're actually doing a lot of high-level thinking. And if I just come and dictated it all to you, you wouldn't be able to. So for me to let you struggle with for a little bit, that's really good for you. You need to realize in your life, struggles make you strong.
If you can't. Like,
Jesus lets you go through struggles, not just because he's terrible, because he wants you to learn. Zach, what were you saying?
So if you don't have the 3, does that mean that you just combine everything that's like not? It's not like a clear cube root. Like you can get a cube root out of 3 cubes. So like
Yes.
you just combine everything that's not.
Yeah, you combine everything that's left over. Yes. That doesn't come out. That's exactly
If
right.
you had 2 cubes, you would still combine it with the 5.
Yes, because it's not triples. Yes. Very good. All right. Sometimes it's obvious without factoring. I want you to watch this. I have 300 right here. And if you wanted to, since it's a perfect square root already, you wouldn't have to do your factor tree. You could just do it like this and say, oh, that's 10. And what's left over in the inside?
3.
3. JD, many textbooks teach it like
Would
this.
you do parentheses over like just around
You could, but you don't have to.
just to make it clear?
If you think it's clearer, then do that. To me, I don't like to write any more than I have to.
I know, but it just kind of looks well like division
Right.
or like fifth root.
Oh, I see. JD, some textbooks teach it like this. You look at 100 to 300 and you try to think of all the perfect squares that could divide out. And for me, sometimes I can't think of them. And so for me, I need a procedure. I always do with my prime factors.
Yeah, I think I did something like this in pre-op.
But as you're doing prime factors, is if you come across a perfect square, don't break it up. You can just leave it if you want. Okay? All right, let's go to your textbook. Let's go to your textbook. 1, 2, and 9. Notice it's 1, 2, and 9. Something happened here. 1, 2, and 9. Two square roots and a cube root.
It's 96, I think. So I think it's
Did I do it wrong?
no.
No.
So that's how I did it. They're just
But I was
trying to
thinking-
figure
Go
what
ahead.
to divide it by.
Oh, I see.
Isn't it?
14 and 7.
Oh, you
Well,
could.
that's
Yeah.
what
Okay. Is that what,
it-
okay. So for me, if I don't know something really high, I know it's even. I automatically just start with 2. Okay, you did the prime factors, correct? Oh, do number 1 first.
Yeah, but I was going to start with this because
Okay. All right.
I guess yeah.
All right.
It would be easier to do it elsewhere, I guess.
And then actually do all the prime factors first, and then we'll go.
Oh.
Okay.
360. Oh wait, is 7 cubed? Is it 363 or is it 340?
I don't know. You are better at all just jumping. I have to read. I have to do the song all the way through.
363, yeah.
Is this a perfect cube root?
I think it's 343, isn't it?
Yeah, it's 343.
I did that really little. I don't know why I did that so little.
Trying to figure out the cube root. How 48 could get to a cube.
Wait a minute.
Check my prime factors. Make sure I did them
Oh.
right. All right. Give me a hands up when you've gone as far as you can go. You can't go any further. I've got 2 people, 3 people are like that. All right? You've done as much as you know how to do.
It makes no sense to me at all.
Okay, so have you done the prime factors at least? Do your prime factors at least. Try that part. At least get that far, okay? If you can't go any further, that's okay. Okay, so then you put all those inside. Let's do the first one together. Let's do the first one together. I've got 98, and I did the prime factors. Raise your hand if you agree with my prime factors. 2, 7, and 7. What do I put underneath the radical?
2.
I'm going to put them all. 2, 7, and 7.
2, 7, 7.
2,
For now.
7, and 7 for now, okay? Because what is 2, 7? When I multiply 2, 7, and 7 all out, what do I get? 98. Okay, so I really haven't changed. The problem is the exact thing. It just looks different. Instead of a 98, it's 2, 7, and 7. All right. Am I going to circle doubles, triples, quadruples? What am I going to circle?
Don't.
JD, why am I circling doubles?
Because it's square.
Because it's a square root. All right. Ashton, of 2, 7, and 7, what are the doubles?
7.
7 and 7. Okay. Remember the thing at the top? It said the groups come out as singles. So what goes out front, Ashton?
49.
A single.
Seven.
A single 7.
You're square rooting it, so if you have 7 times 7.
Yeah, because the 7 and the 7 is 49 in a sense, and that comes out as 7. And then I put the leftovers back inside. All right? Zeb, what is the leftovers? Very good. So
Good
that
job,
is the answer.
Dad.
Okay? Ashton, please ask me some questions.
Please, Ashton, she's begging you.
I am. Go ahead.
Let's go to the next one and see.
Okay, see if that, okay, all right.
Makes any more sense.
All right, so do you agree with me on my prime factors right here, 3, 11, and 11?
Yes.
Okay, so what am I going to put inside, Ashton?
You're going to put 3 times 11 times 11.
Okay, all right. Raise your hand if you agree with Ashton.
What?
Raise your hand if you agree with Ashton. Okay. Zeb, am I going to take out doubles, triples, or singles? I'm assuming, yeah, doubles, singles, or triples.
No.
Why am I taking out doubles, Zeb?
It's weird.
Because it's a square root. That's right. All right. What are my doubles right here, Zeb?
11.
11s. All right. Ashton, you agree with him?
Yes.
All right. What am I taking out, Zeb? Zeb, what am I taking out?
3.
I remember the groups come out as singles. We just
11.
11 comes out. What's
Maybe-
left in?
Mama.
Shh, no. What's left inside, Zeb?
3.
All right. So the square root of 363 is 11 times the square root of 3.
Keep your 38.
All right.
I can't be reduced to-
Now let's do number 3. Okay. So we're going to go here. Why didn't I write a prime factor for 98? Why did I not write a prime factor for 98 again?
It's not possible. Oh no, you can prime factor.
Because I already did it over here, right?
Oh, yeah.
Okay, so I already did it. Are we ready? Okay, so we're getting some big old distractions here. I was hoping he could come out of it, but he's not coming out of it. It will be back to you soon, okay? Don't stress, it's not taking forever. All right,
Zeb.
here we go. What goes under here? What goes under my radical?
3.
There's no 3 that goes underneath there.
2, 7, 7.
2, 7, and 7. Ashton asked me some questions. You're looking like you have a furrowed brow. Like, where in the world did she get those numbers?
Those are the same ones as the other 98. So
Yeah, I did the 98 one over here earlier. And I got 2, 7, and 7.
I know where you got the numbers.
Okay. All right. Now, hey, Ben, am I going to take out doubles or triples on number 9?
On number 9, triples.
Triples. Where are my triples?
Nowhere.
There are no triples. Let's read the instructions to the top. Simplify the radicals, what? If possible. Show the factoring of the radicals in your answer. If it cannot be simplified, what do you write? Cannot be. Now, you do not write null set because that means there's no
There's nothing ever possible.
this means that you just can't do the problem, okay?
You can do the problem.
You can do the problem, and the answer is the cube root of, so that you'll write cannot be simplified.
would you also circle?
You could just circle,
98
yeah.
too?
And they're probably in the answer key going to say cannot be simplified, though, okay? All right. You have just learned
Yay.
how to simplify radicals. So for some of you, this is the very first time you've seen this. For some of you, it's a review, but there still was like pulling up, oh yeah, okay, I think I know, but next week, don't forget, you're having a quiz over the whole thing of your Cartesian coordinate system. We are finished.